Hello, everyone. Welcome back to CMPT 456, Information Retrieval and Web Search. This is the second part of the section, Evaluation. In the first part, we discussed the basic concepts of evaluation, the task, and also some frequently used evaluation data collection. If we have a large collection of documents, even we have the information need, and it is still very challenging and almost impossible to manually evaluate the relevance of every document in a large collection against the information need. How can we solve this problem? How can we effectively use multiple judges to provide us the relevant information about documents and the query? Pooling is a frequently used approach. The idea of pooling is as follows. We take a set of search engines and algorithms. In order to make a pool, we feed the query to those search engines and algorithms and ask them to produce the sorted list of documents. For each algorithm or search engine, we take the top K results, where K is typically a small number, like a 20 to 50 in the TREC task. Then we merge those top results into a pool and remove those duplicates. The idea behind this is that hopefully those top results produced by the search engines and algorithms contain a good number of relevant documents. This, to some extent, is similar to the idea of pseudo user feedback. Then we present the documents in a random order to the analyst, to the judge, and ask them for the relevance judgment. In reality, people find that the relevance judgment produced by the pooling method are complete enough to produce accurate comparison for new search techniques. However, it does not mean the pooling method works everywhere. Still, there are some situations where the pooling method may not work well. Can you imagine in what situation it may not work well? One situation it may not work well is the following. Now, you have a new algorithm or new search engine. That this algorithm or search engine is very different from the other search engines and algorithms that make up this pool. It finds many relevant documents that are not ranked high by those search engines and algorithms in the pool. Then, correspondingly, using the pooling result may not give your new algorithm a high evaluation matrix. This is not because that your new algorithm is not good. It is because your new algorithm is very different from the set of search engines and algorithms used to produce the pool. So, in other words, in this situation, the pooling technique does not work well. We mentioned that we will use multiple judges to produce the relevance information. Then you may ask, how can I know whether those judges are consistent with each other, they agree with each other? Typically, this is done using some statistic approach. Kappa Statistic is one of such approach. Essentially, Kappa Statistic is for categorical judgments and corrects a simple agreement rate for the rate of chance agreement. Kappa Statistics, the formula is very simple. It is PA minus PE divided by 1 minus PE, where PE is the probability that the judges agree with each other by chance, and PA is the proportion of the times that the judges agree. Why Kappa Statistics? The intuition is very simple. In the perfect sense, in the perfect case, the judges agree with each other all the time. So this is 1. And this is the probability that the judges agree with each other by chance. So 1 minus PE is the best situation where the judges are agreeing with each other. PA is the observed proportion of times that the judge agree. We still minus PE. So if we use this PA minus PE divided by 1 minus PE, we are calculating to what extent what we observe is approaching the perfect situation. That is the intuition behind Kappa Statistics. In order to calculate the Kappa statistic, we often use the marginal statistics to estimate this PE. Let me show you one example. Suppose we have two judges, Judge 1, Judge 2. Each judge look at the data and give his judgment, either yes or no. And we have this confusion table here, and we also calculate the margins here. The observed proportion of times the judge agree indeed is 300 plus 300 is this 300 plus this 70. Those cases the two judge indeed agree, right? So in total is 370. But in total we have 400 cases. Therefore, the proportion that we observe the judges agree is 370 divided by 400, and thus is 0.925. Now, we need to estimate PE. There are many different ways to estimate PE. Here, we introduce a conservative way. We use the pooled marginals. So first, we calculate the chance that the a judge, no matter it's 1 or 2, may give say non-relevant judge. And we look at the non-relevant judge here is 80. And we look at the non-relevant judge, this here is 90. Okay, so among those 400 cases here, 80 of them are non-relevant judgment, and on all those another 400 looking at this direction, 90 are non-relevant. Relevant. Therefore, we have this 80 plus 90 divided by 400 twice, because we look at it from this order and also from this direction. So we have 400 twice. And in total is 170 divided by 800, and this gives us the probability of 0.21. Similarly, we can calculate the probability of relevant, which is, let me clear the screen and then come back. So for the relevant, we see these 310 here, and we see these 320 here. Again, we look at these 400, we see 320. We look at these 400, we see 310. Therefore, we have 310, 20 plus 310 divided by 400 twice here. And that will give us 0.078. Then if we take these two marginals, and then we can calculate the probability that the two judges agreed by chance, which is each one independently say non-relevant, which is this part, or each of both of them independently say relevant, which is this part. So by calculating this, we get the probability is 0.665. So the Kappa statistics is calculated using 0.925, which is obtained here. Let me use the pen. So we get this one from here. And minus these 0.65 here, divided by 1 minus 0.65 here. So we get 0.76 as the final result. So in the previous slide, we introduced how to calculate the Kappa statistic. Kappa value is 1 if two judges always agree, as we explained as the intuition. And it is 0 if the two judges agree only at the rate given by chance. And it is negative if they are worse than random. It can be negative because if this PA is even lower than PE, meaning we observe that the probability the two judges agree with each other is even lower than we calculate the expectation using the marginals. So if there are more than two judges, we can calculate the average pairwise Kappa value. That is, for every pair of judges, we calculate one Kappa value, and then we calculate the average of all those Kappa values. If we have n judges, we will have n times n minus 1 divided by 2, that many possible pairs. As a rule of thumb, a Kappa value between 0.07 and 0.8 is considered a fair agreement. If the agreement is below 0.76, meaning 2/3, it can be regarded as data providing dubious bias for an evaluation. That means the judge may not agree with each other.